Today we're going to see about YOLO concepts. So YOLO means you only look once. So now tell me Gautam, so what are the objects you are looking in this look at this picture?
The animals are there.
What are
Uh,
the animals? You first what which animal have you seen?
the jaguar.
Jaguar, okay. And then next, what are the animals you see?
On the right hand side, elephant, bear, monkey,
Deer, okay.
chimpanzee, tiger.
Okay.
I could say.
Okay, the same concepts, Gautam. So you only look once means once the camera or surveillance are watching. So in real time, we are using this object detections. Where means in our traffic signals, there are many surveillance cameras are there, and they are checking whether we are wear a helmet or not. So first, it will check the bike. He's on bike, so if he not wear the helmet, so it will automatically put the fine on bike number. Have you got it?
Correct, correct.
So it automatically detects the object. So here it detects the objects like elephants and monkey and bear and tiger, chimpanzee, jaguar. So here the snake will
I
not
could say
detect.
python as well. Yeah.
Yes, and the snake will not detected, Gautam. The python snake will not detected. I tell you. So it first the surveillance it automatically as a grid pattern. Okay, so it's in grid pattern. See the forehead of elephant. See the forehead of elephant. So this is a point,
Yeah.
right? So this is a point. So here one threshold value will be there. Here one threshold value will be there. So I just given 50 percentage. It means 0.5 will give. So is the elephant head is above 50 percentage?
No, I think.
Yes, Gautam. So it's above 50 percentage, right? So this is the 40
Uh,
percentage threshold value.
Okay,
So
okay.
see,
So you are
see,
giving the threshold value to that particular grid only.
yeah. So
Okay, okay.
here I applying for beer. So
Hmm.
let's see here the above 50 percentage.
Yes.
Now tell me what about the snake?
The head is not in
Uh
the above 50 percentage
yes.
threshold.
So now the grid is 4x8. You can change the grid as grid pattern sizes. Okay. So
Okay.
if the grid is 4x8, so the grid will be shows like that. So it automatically detects the tiger and chimpanzee and monkey and jaguar. Okay, this is the centralized point. So see the beer. So this is the centralized point. So this is x-axis and this is y-axis. Have you got my point?
Yeah, yeah.
And this is the height, Gautam. So this is the height, this is the height, and this is the width. This is the height and width. So it find the classes, Gautam. So first the object will see this one. So first the object will displays as a boundaries. Okay, boundaries. So elephant has rectangle boundaries and jaguar has orange boundaries. So this is the boundary boxes. We call it as
No, yeah.
boundary boxes, and the next one is confidence score will be there. So while we are waiting our buses, we will see the road, right? So from far the bus or lorries or any other vehicles will come, right?
Yes.
We will guess if it is lorry, we also deciding, so some bus will be coming there. We will decide, right? The
Yeah.
score value difference, Gautam. If it is surely it's elephant, you just check elephant or toy. Surely it's an elephant. It automatically score is 98 percentage. Have you got my point?
Okay.
So if it is less, the score will be reduces. It means what is the lowest percentage? Here the monkey and beer is the lowest percentage, like 50 percentage. The score value will be reduced, right?
Yes.
So in case here the one object will be here one object will be detected. So here also the score value will be reduced, like 30 percentage. Here the score value be 30%, or rat or any other thing. I just You just assume that. Okay. So
Yeah, yeah. Okay,
if
okay.
it is so far, the score value is reduced. If it is nearest and confirmly this is the right object means, so it automatically deducts the score as a highest percentage. Have you got my point?
Yes.
Now you know x grid y and grid and threshold value, and you already know the height and width, right? I already drawn in the B, right?
Yes.
Have you understood, Gautam?
Yeah, I got it.
Uh,
So whenever a camera or anything that sees about anything, it will
uh,
calculate in the background in the grids pattern.
yeah,
And when the pattern is divided into grid x-axis and y-axis, if the
yes,
image or the head of that object is above 50% threshold,
yeah,
then the deciding factor will come into the picture.
yes,
If
yes,
the background process matches with that image, then it
mm.
will give the answer to you.
Yes, Gautam.
Depending on that percentage only, the image will comes out.
Yes, that's not a percentage.
That is
It's a
called
score value.
confidence score.
Score.
Hmm.
Yes. Have you got it?
Got it.
Yeah. Okay. Just take a snap. I'll move on theory concept. Just take a snap.
Yeah, done.
Okay, so let's see. So YOLO is a you only look once. So this is a real-time object detection algorithm. So it can detect multiple objects at a time. It may be image or video. So it may be image or video in a single forward pass. So single forward pass means input layer, hidden layer, output layer. So that's a unidirection, right, left to right. So that is called single forward pass. So of neural network. So this is mainly using for classification and localization. Okay, localization means location where it present, and so classification is what is it, in which class. So it's a person or bicycle or elephant or tiger or any other classes in into the single model. So widely they are using in data science. So especially they are working with computer applications. I already told, right? Surveillance also they are detecting the people and weapons. Okay, in autonomous driving car they are using detecting pedestrian and signs, right? So in
Oh
in
yeah, yeah,
in,
yeah.
in our
In
road
Tesla,
also
you
many
can
signs
find.
are there,
Hmm.
right? You turn left or right, and
Yeah.
smooth curve, right?
Oh, I think depending on these technologies only, like the Tesla, the auto
Yeah,
self-driving
yes,
cars,
yes,
or
yes,
the
yes, yes,
delivery things will
yes.
be.
Otherwise it will not work. So without computer
Okay.
vision.
Okay.
And in medical image it automatically detects the tumors, cancer tumors.
Oh.
So, doctors, you already know the Gautam. So, some doctors are told like, so your heart in small hole will be there. So, they are finding with the object detections using the deep learning concept.
Okay.
Okay, and smart agriculture also they are using. So, in tomato plant, you already know. So, if the tomato is full and fully is red in color, so it's a fruit, right?
Hmm. Correct.
So if it is green, we will not plug the tomato. So if it is
Correct.
red
Correct.
color, we
Correct.
automatically plug. So we can use our drone cameras or any other small
Hmm.
robots. We can easily detect the fruit detection.
Hmm.
So whether the fruit is in disease affected by disease, it also have the solutions while using the diseases. So if you are taking any disease plant in your Google Lens, it automatically find the disease, right? So it may be
Yeah.
causes by these insects or any other soil fertilizers like sunlight like damages. It automatically detects, right?
Yeah. Yeah.
So these are the things we will be
So,
using.
in the medical field, let
Hmm.
us assume
Hmm.
a doctor is using this YOLO concept
Yeah.
and uploaded any report. Like
Uh,
we'll take an example of X-ray. Okay,
yeah. Yeah.
so this YOLO will scan the entire X-ray and will say if the tumor is present or not.
Yes, but in
But
X-ray,
how?
Gautam, in X-ray
Hmm.
only we will see the bones only. Okay, in
Yeah,
MRI,
correct.
MRI scan only we will see the organs.
Which scan?
MRI scan, we will.
MRI. So let us example. Let us take an example. We are looking at an MRI scan.
Yeah, yeah, yeah.
Okay, in that MRI scan, doctor is asking this YOLO to find out whether the tumor is present in that or not. Correct.
Hmm.
So, what is the data that is feeding YOLO in the background to say
Hmm.
whether the tumor is present in that MRI or not?
Gautam, we are already trained by a lot of images.
Okay, already we have trained, or we need to train using this concept.
Yes.
We need to train, or it is already been trained in the background.
But now it already trained, so we can easily
Hmm.
use the concept.
Okay, so
So,
if in case in future,
mm,
if any person, if any doctor comes to our organization
mm,
asking for a similar kind of help for the similar disease,
yeah,
then we need to use this concept and train our model to detect the anomalies.
yes.
Okay.
So have you seen? So here they are using CNN and RNNs.
Hmm.
So mainly it's a deep learning concept. So it find the cancers or some diseases,
Anomalies, any other
yeah,
differences. Hmm.
damages. So
Got
in
it.
X-ray we can see the bone damages, right?
Correct, correct.
Mm,
Bone density also we can find.
yes. Yes, these are the things we can using deep learning concept. We can see our bones.
Yes.
Mm. So come to the topic. So how YOLO works means first it takes the input Gautam. So it will takes as any image. So it may be any pixels. Okay, it may be any pixels. Okay, height and width. And the image is divided into SS grid. So image should be in same grid Gautam. If the height is 5, width also 5. If the height is 8, the width also 8 Gautam. Have you got
Okay.
it? So and the next one is grid responsibility. I already told, right? First is it object is detected by center lies. I draw one point, right? Draw one point in
Yes, yes, yes.
B, right? So
50%.
the center lies point. The point will
Okay.
and predict the boundary boxes using x and y width and height, and confidence score will be shown on each boxes, and the class probability will be shown class probability. So if it is a tiger or elephant or any other object, the class probability will be displayed. Have you got my point?
Yes, yes.
And the bounding boxes also, each prediction box contains what I already told, right? So grid cells have x and y and height and width, and it also have a confidence score.
Correct. Boundaries, confidence score.
Yeah. Okay. And one more thing, in conference score, we are using box and IOU. It means intersection over union. So between predicted box and grounded box. Now tell me, Gautam. So what is grounded box? So grounded box means so the assume that the tiger. So the tiger has in four box, right? The tiger has in four
Correct.
boxes, right? So this is the ground truth. Okay, this is the ground truth. The predicted box is in brown color, right?
Yeah, yeah, yeah.
Hmm. This is the intersection over union. Okay.
Which means the head related part. Huh?
Yes, yes. The particular object. It detects the predicted the box.
Mm-hmm.
Hmm.
Okay. So the entire panel is ground box,
Hmm.
but the predicted box is the head one, or the
Yes.
classification that has been happened using that particular box.
Yes. This is called intersection over union.
Okay. Okay.
Mm. And the next one is, so we move to class prediction. So each grid cells will be predicted as a set of class probability. So it may be any objects. And these are the mainly using condition probability from 0 to 1. So 0 to 1 means it's 100%, right? So if it is 50%, it assumes as 0.5. Is
Yeah.
and the final output you will get the set of box with class name and conference score, and here they are using non-maximum suppression. Non-maximum suppression means it removes the duplicate boxes based on IOU threshold. So it removes the duplicate boxes, Gautam. So here the box is no needed, right? So in tiger the
Correct.
box is no needed, right?
Mm-hmm.
So it automatically removes.
Okay.
Hmm.
Okay.
So only deducts the tiger object only. Have you got?
Mm.
Yes.
Even though if this is related to picture,
Hmm.
like an example that you said, in a moving traffic,
Hmm. Yes,
or
yes,
any
yes.
vehicles that are moving in that camera perimeter,
Yes.
the box also will move according to the object.
Yeah, yeah, Gautam.
You got it.
So after the class, we will see the video of using YOLO. Okay.
Mm, okay. Okay.
And next, so this is the concepts. It works things on YOLO. You can just use your chat GPT and you can see the YOLO architecture. So this is very important. Okay. So you have to know this architecture. Okay.
Okay.
Okay, it's just a key concept. So we already know bounding box, class probability, conference core, IOU, non-maximum suppressions. So this is the YOLO architecture. First one, we are using convolutional layer. We just extract the features. Using convolutional layer, we can extract the feature. Just take the tiger image, Gautam. Yesterday we seen, right? So in CNN concept, feature means it extract the features: tiger eyes, nose, mouth. We will find with the help of eyes, right?
Yes.
Gautam, if you are extracting this feature, if you are extracting tiger eyes, you automatically find it's a tiger eyes. You automatically find the feature name,
Yeah,
right?
yeah.
So on mouth
Correct,
also it's
correct.
a, so this is the extract the features using convolutional layer. We will extract the features and it
Oh,
convert as a numeric values. Okay.
okay, okay.
Then fully connected layer will be what? Predicted, right? So Gautam, this concept will continue with CNN concept. This YOLO concept will continue with CNN concept. Okay, what it does? So CNN automatically predict the animals, right?
Yeah, yeah.
So here we predicted tiger. Then only the output will be grid and pattern will comes and to find it's the tiger. So it find the object. Have you got my point?
So this YOLO is maximum built upon or an advanced
Uh,
version or the background of a
not
CNN.
not advanced version. It's the top of made by CNN.
Okay, okay.
Okay, the first you can split into two parts. YOLO as the first part will be CNN, and the another part will continues to find the object.
Got it.
So if you can search ChatGPT, so it will be superly. They will given the points.
Okay.
Okay, then so it's just an example. Okay, so no needed. Uh, So it means SS grid. So grid has seven grids, and the bounding box is 2, but the class is 20 classes. Now we can see the classes 7 cross 7 grid and 30. Okay.
Okay.
So see the next one, and here also we have the loss function where we are checking the loss functions here. Local maximum, we will get the localization loss, or conference score loss, or we will find the classification loss, right? So we using
Yeah.
mean squared error, we will find the localization loss, and here also we will find the confidence score loss. If the predicted object score is less, it means actual presence of object and no object. Sometimes it will predict the no object, right?
Yeah.
So Gautam, while they are making cake or chocolate, they will make like animals, right?
Yeah.
But the cat in cake, but real cat also different, right? Both are different, but the object will not define the better. Have you got my point?
Which one is the better one? Which one is
Which
the
one is the
real
real
one? Which
object?
one is the artificial one?
Yes, yes. If it is deducts both are real, so it's a wrong answer. Have you got my point?
Correct.
So real cat is
Correct. Correct.
different and the cake cat is different, right?
Correct.
So that then only we are using confidence score here. So it's 100% it's a cat. So 90% or 50-60% it's a cat. So that's a confidence score loss. We will check.
Okay. Okay.
Okay, and classification also we are using. Here we can updated the weights. So basing on relevant prediction model. So these are the YOLO version, Gautam. From previous to now, V1 version 2 3, and now we are using version 6 or 7 8.
Okay.
Okay, depends on different improvements. This is faster but lower accuracy. So here accuracy is improved. Here more multi-scale prediction. So little much they are detecting using for segmentations also.
Okay.
Have you seen, Gautam? They are drawing with their fingers in air. Have you seen?
Yeah, yeah. Some Instagram videos I
Uh,
have noticed that
yes,
they are
yes.
writing something and using another option, duster, like a duster, they are removing
Yes, yes.
using fingers only.
Yeah. So they are mainly using for deduction and segmentations also.
Okay.
Same deep learning concepts. They are using. There are many algorithms will be there, Gautam. But this is
So
a
it all depends on if you are seeing me on the camera, the entire background is divided into grids, and whichever grid I am taking an action,
mm,
depending on the action and depending on the option that I have taken, it is
mm.
doing the work. Am I right?
It will takes as an image as a graph,
Hmm.
Gautam. So if my image
Okay.
will be there, so it automatically takes as a graph view. So if my axis, my finger point is 1 point, so it automatically detects the coordinate points x and y.
Hmm. Got it.
While moving the axis, it automatically detects the points.
Okay. Okay.
Hmm. So there are many applications are there. So healthcare, tumor, cell detection, and security weapon in retail, people counting. So we can using for attendance also. If how many peoples will come to present in our classes also.
Yeah, like if you go to any DMart or any retailer shop,
Hmm.
there won't be any person counting the people how many people are coming into the mall and how many people are going out of the mall on a daily basis,
Yes.
right?
Yes. Yes.
So these
Yes.
cameras will count, I think.
Yes. And transportation also and agriculture also, there are many use cases are there. Here I given a few only, okay. And
Okay.
you can install the pip install ultralytics, pip install ultralytics, open the command prompt and just install the ultralytics, okay.
Okay.
Okay, so here is YOLO version 8 nano dot PyTorch will be there. So you have to download this one. I will tell you how to download the PT file. So here I downloaded the PT file. So YOLO 8, see here, YOLO version 8 nano
Yeah.
dot PT. I tell you how to download. Okay.
Okay.
So you can download the iris PNG image, any image. This is one image, Gautam. I taken from the website. You can search any images. Okay.
Okay.
So first you have to this is the framework. You are from Ultralytics. You are importing the YOLO
YOLO.
and the Matplotlib we already know. So here the main thing is computer vision. This only detect the object. Without computer
Okay.
vision, we will not detect, never detect the object.
Okay.
So this is the computer vision. We call it as CV2.
Okay.
Hmm. And the next one is YOLO. You just load the model, and the next one is you just give the image, and we will. So you will check the results. So you will check the results as a zero. So it will plot as a anot image. I'll show you. So this is the result, Gautam. So this is the result. So only they will train by 80 objects only, Gautam. You can use any images. You can use person or bicycle, car, any image you can give, download and give it.
Okay.
But they are only trained with 80 images, Gautam, in this trained data set. So in this trained
Okay.
means
By default.
so by default means so you are downloaded, right? YOLO version 8 nano.pt,
Okay. In that
that we are
YOLO
already
version,
trained.
that 80 objects are there.
Trained.
Okay. Already trained.
Yeah.
Okay.
Have you got my point?
Yeah. Yeah.
So, but here I'm only taking the results as a zero. So only I am taking as a result as a zero. So you can see, so this is the zeroth index. So now see here, what is the zeroth index now? So these are the things are zeroth index. So this only displays the column. Have you understood? Yes. See here, Gautam. Just we are plotted, and the next one is we will convert as a BGR to RGB. Then only you will see the graph. In OpenCV, in Open Computer Vision, it automatically takes as a BGR. Okay, you have to convert into RGB for Matplotlib. Have you got my point?
Okay. BGR means
Blue,
blue,
green,
green,
blue,
red.
green,
Huh?
green. It's a
Okay. Okay.
RGB, red, green, blue.
Okay. Okay. Got it.
So you have to convert the color using computer vision. You have to convert the color from color BGR to RGB. Okay, so
Okay.
this is our image. This is our image. So it will show us as a graph.
Okay.
So this is like a parted plan. Not sure for 100%. It's just show as a 36%. Have you got my point?
Okay.
Hmm. Nothing. Otherwise, nothing, Gautam. So
Can
this
you
is
please tell me the difference between the zero and results zero and with
Yeah, it
Indexing.
is.
You said indexing, right?
Yes,
Zero
yes,
and
yes, yes, yes. Gautam, I now print the results, right? So it automatically prints the all the things, right?
yeah, boxes, key
If
points, masks. In the
if the
names column, you can see dictionary.
result zero means it only prints the zeroth index. It only prints the zeroth index.
Still, I didn't get. Can you
If
please tell me the direct difference?
yeah, tell you Gautam. So in array you are using array of zero, right?
Correct.
It will display the zeroth index only, right?
Correct.
Same here, the result also display the zeroth index only. It will only plot the zeroth index only.
Okay.
Hmm. Wait a minute. See here. Have you seen?
Oh yeah, yeah, yeah. All the results have gone. Now the only
So,
array matrices
Gautam, the
are available.
image will be converted as a matrix, Gautam, here.
Okay. Okay.
Okay, we can easily assume that.
Hmm.
Hmm.
Got it.
So, if you have any doubt, you can just give it the line and run in the cell. You will get the answer.
Oh, okay.
So, here the results. Only if you are given zero, it only takes this one.
Oh, okay, okay. Got it.
Okay. And that's all, Gautam. You can try any images from these objects. Bicycle, car, motorcycle, aeroplane, bus, or many 80 objects are there. You can use and predict the images.
Okay.
Okay, I tell you how to download. Okay, so this is the concept I already told, right? So I just scroll the pages. Do you have any doubts from today's topics, Gautam?
Nothing as of now.
Okay.